information, I think I'll just finish explaining all the questions, then you can do the corrections. Okay. Let's take a look at question 6 though. Question 6. Where is it? Okay, question 6. Now Alice and Betty, they have 3,216 stickers altogether. Now after Alice gave Betty 180 stickers, she had 3 times as many stickers as Betty. How many stickers did Betty have at last? Okay, first of all, Steve can tell me how should we draw the model for this question? Oh, we draw Betty first. Okay, so Betty has 1 unit. Then how many units will that be for Alice? 3 units, perfect. Alice will have 3 units over here. Okay, 1 unit, 1 unit, and 1 unit. And then, what else information are given to us? Oh, they have this amount of stickers altogether. So this is the scenario at what time? After Betty gave 180 to the Alice. But will the difference change? No, the sum always remains unchanged, which is 3,216. So what is the value of 1 unit now? How to compute it? Yes, so 1 unit equals to 3,216 divided by 4. This will give us 804. So 1 unit is 804. Then, we want to find out how many stickers did Betty have at last. This is a scenario at what time? After, right? So this is at last. Now, how many stickers does Betty have? 1 unit. So, question A, Betty will just have 104 stickers. How about question B? How many stickers did Alice have at first? This time, Bernice, can you explain to me? So, can I tell you first of all, at first, or at last, how many stickers does Alice have? This times 3, excellent. Now Alice at last will have 804 times 3. This will give us okay, 2412. And then how many stickers did Alice receive from Betty? Oh, Alice gave something to Betty. So before, at first, how many stickers does Alice have? Ah, 200 plus 180. So Alice, at first, will have 2412 plus 180. This will give us 2592. So that is answer for question B. All right. Okay, now let's take a look at question 7. question 7. These two people, they have the same amount of money at first. After Ahmed had spent $37 and Jack has received $15, Jack has 3 times as much money as Ahmed in the end. How much more money did Jack have than Ahmed in the end? Okay, then how about let's first draw a model for the before scenario. Before, these two people, they have the same amount of money, right? So this A and J, they have the same amount of money. This time, what happened to A and J here? Afterwards, over this. A has spent $37, right? So how should we draw this $37? So, to the left, okay. So this $37 has been spent out. And how about for Jack? Jack received $15. So this part has been received by Jack. $15. Then what is the new difference now? So how much more money did Jack have than Ahmed in the end? And what's the new difference? Sorry? 22. How do you know it's 22? Now, how do we indicate the difference? You see, if we draw a line over here, and we draw a line over here, this is the new difference, right? So how do you compare this new difference? 37 minus 15. How do you compare this length? Well, is it plus together for a bit. So 37, you plus 15. This will give us $52. Okay. So actually for this question, this 3 times is actually useless. Just using these 2 information, we'll be able to find out the difference. Because actually this question is the first small question of this question 7. There's actually another small question. Okay. Okay, finish the correction. Alright. Then let's take a look at question 8, the last word problem here. Okay, in this word problem, fruit seller has 580 green grapes and 235 red apples at first. Now, after selling the same number of each type of apples, they're all apples. There were 4 times as many green apples as red apples left. How many of each type of apples were sold? Okay, so everybody is looking at this question now. Question 8. Okay, first of all, at first there are 580 and 235 apples, right? So for the red apples, you have 235 apples. And for the green apples, there will be 580 green apples. Now for the red apple, total here is 235. For the green apple, the total over here is 580. Now maybe Christelle can explain to me. After selling the same amount of apples, how do you represent the same amount here? So how can we represent the same amount over our bar? They sell the same amount. Choose like a small one. Okay, the same like this. So this part has been sold away. Okay, for the rest part, that means this long bar now is 4 times the red apples. So this is 1 unit left, and for the green bar, you will have 4 more units. 1 unit, 1 unit, 1 unit, and 1 unit. This sense, can you tell me? This is what kind of problem here? You see, both of these two bars, they go through a decrease. So it's called a common decrease problem. So just remember when doing the common decrease, when finding the difference, what should we do? Does this affect our difference? This one. If you do the subtraction of these two, will the difference change if you know or do not know this value? No. So what is the difference now between these two? 3 units. Yeah, the difference here is 3 units. But what is the difference in terms of value? What is the difference of the value here? Yes. 580 minus 235. This will give us what? 5, 4, 4, right? 445. 8. Wait a second. This should be 3. 345. Alright, that's right. Yeah, 345. So 3 units now are equivalent to 345. So 1 unit will give us 345 divided by 3. This is just 1, 1, 5. So 1 unit equals to 115. So how many of each type of apples was sold? So you can tell me, for example, for the red apples, how many apples are sold? 235. Excellent, minus 115. And then we'll get 120 apples that is being sold. So this is for the red apples. How about the green apples?
Green apple is 580. And then minus 115 minus 115 minus 115.
Okay, times 4. Now, and yeah, that's the result. And you observe that these two values, they're actually the same, right? So if our red apples have 120 sold, how about the green apple? They're the same, 120. So we can just write directly 120 here. So the answer is 120. Okay. So this kind of problem is called a common decrease because both of the two bars, they go through a common decrease in this part. Okay. Alright, moving on, I want to explain some calculation practice here. So, okay, some people may wonder how to solve this question. 4,500 divided by 45 divided by 4, right? Now you still remember when you are doing this division with a bracket? If we're going to remove the bracket, what should we do? First of all, previously we see that 100 divided by 4 divided by 25, this equals to 100 divided by 4 times 25, right? Now similarly, if you want to break your bracket in front of a division sign, you need to change the sign over here. You see, if we have a times sign here, and then you want to remove this bracket, then it becomes a division sign. But similarly, if you have a division sign here, for example, 60 divided by 15, then if you want to break this bracket, this will give you 100 divided by 60 times 15. So the sign here always need to be changed. Now similarly for this question, here in front of it is a division sign. So if you want to take out this bracket, this sign should be what? It should times, perfect. So that means, you see, first of all, 45 divided by 4, you can't get a whole number result, right? So we should break this bracket now. 4,500 when divided by 45. You need to times this 4. Then we can just solve it in order. 4,500 divided by 45 equals to Christelle? I mean this one. You can just solve it in order now because this division is very simple. Yeah, it's 100 and then times 4. So it is just give you 400. Okay. Similarly, for this question, we are dividing two numbers together, but this time because 4,500 divided by 25 is not that easy to find out. Then we can try to add a bracket. Previously, we break this bracket. Then, in front of it is the division sign, you need to change the sign. Similarly, if you're going to add the bracket over here, inside it is the division sign, again, you need to change the sign. So this sign should be also changed to times. So this will equal to 4,500 divided by 25, then times 4. Now, can you tell me what is this product? Still remember? 25 and 4. Okay, let me write on the calculator. 20. 2 times 4 equals to 8 plus 2. 10. So 4 times 25 equals to 100. Now, again, this is a very important number. 4 and 25. They multiply give you 100. Okay? So 25 times 4 equals 100. This becomes 4500 divided by 100. And the result is just 45. Okay. And see. Oh. The last two questions now. This one. 3 and 2 over 5 minus 1 and 6 over 7. How should we do this subtraction, Christelle? Can you tell me when doing subtraction of the mixed number here? What should we do? Equal fraction. Okay, of course you can do that. Change this to equal fraction and this to equal fraction, right? But remember in class we have also mentioned that you can group the whole numbers together and the fraction together, right? So let's first do this 3 minus 1, and then you do this fraction, the minus together. Now 3 minus 1 will give you 2, and for this fraction it does not have a same denominator, so what should we do first? Yes, Richard? Use one of the total. Oh, but first of all, how do you know it's oh yeah, we first made the denominator same, right? So again, let's try to find out. The multiple of 7. 7, is it a multiple of 5? See. No. The next one is 14. No. How about the next one? 21. No. Next one is 28. No. And the next one? 25. Yes. So you need to make these two both to 35. So for 5, how do you make it to 35?
5
Times What's given?
7.
Times 7, okay. So 2 times 7 also. Then minus 7, how do we make it times 35? 7 times what equals to 35?
7 times
7 times 4? Think about it.
5.
Oh, 7 times 5 equals 35. So 6 also need to times 5. Then we'll obtain 2 plus 14 over 35 minus 30 over 35. And then what should we do now? This one is smaller than the last one. Okay, let me write it down here. 2 plus 14 over 35 and then minus 30 over 35. Yeah, we can borrow some number from 2. We can borrow one number from 2 here. Now, for this one number, if you represent it as 35 as the denominator, what should the numerator be? Also 35, perfect. So then 35 over 35 plus 14 over 35. And then you minus 30 over 35. So now we have this 1, but this sum here is 49 over 35 minus 30 over 35. What is this difference? 19 plus, oh perfect. So 19 over 35. So the answer here it should be 1 and 19 over 35. So that is the answer. Okay. Right. And some of you may wonder, may be curious about the last question. How to solve the last question. So now let me explain this also. But first of all, you need to do the correction for this question. Okay. Times 20. Okay, how to solve this equation though? I have seen nobody have solved this question successfully, so don't worry about that. First of all, let's just observe. In this equation, what can we compute? What can be computed by us first, Christelle? Yes, but then this part you are doing the multiplication, right? And this part you're also doing the multiplication. So this it has a higher priority, so you can't add these two up. Then how about this? You see, 179 and the last one, minus 79. These two at least, because they are doing subtraction, we can put them together, right? So we can first move these two numbers together. Okay. Then what we're left with is terms with 3 multiplications. Just to remember, when there are some multiple multiplication terms, what can we find? We're trying to find out their common factors, right? See, previously you have 5 times 63 plus 5 times 37. Then you extract this 5 out, and these two add up to 100. Similarly, for these 3 terms, are there any common factors? Richard, can you tell me for these 3 terms? This one, and this one. Do they have any common factor? Common numbers? No, right? So these 3 terms does not have a common number. But how about these 2 terms? Yeah, 37. So how about let's first extract this 37 out? See? Again, let's keep this 54 times 63. And then let's extract 37 out. This will give you 37 times 20 plus 34. Now let's try to observe. This is 100 plus 54 times 63 plus this is 37 times 54. This time, are there any common factors? For these two terms, because they are multiplication, they are added up together. Okay. See, for 55, do they have any common number with the next term? Sorry? Oh, 54, yes. So you see, you can imagine this as you have 63, 54. Here you have 37, 54. So what can we do here? Christian? Oh, sorry. It should be 54. Sorry about that. So we can extract the 54 out. Now, plus 54 times. Bernice, can you explain to me? What should I put inside this bracket? 63 plus 37. What is this sum? 100. This is 100. So you get 100 plus 54 times 100. So it means she can tell me what is the answer? 100 plus what? 5,400, perfect. So the answer is 5,500, perfect. So that's the answer. So if you are making your corrections, although you don't have a after class quiz for the day, you will have a homework also. The homework is quite similar to today's exam. This is your take-home practice. So it has exactly the same number of questions and very, very similar type of questions. You can try this at home. First of all, you need to finish your corrections. Okay, this is yours. If you have finished your corrections, then pass it to me. Okay. And also, let me see about it. What else do I want to? Oh, so, okay, thank you. There are a few things to take note. Next week we will have lessons. Okay, and we will have daily practice next week. So this is your only homework. Just do it every day, and then send a photo to me. Okay. You need to finish it at least by next Wednesday. So that means that week when you're going to take lessons, the Wednesday of that week. Okay. Wait a second, let me check your corrections. So if you have made all corrections, you can leave now. Oh, by the way, first I pass you the conversion. I actually okay, no worries. The